Hi there, my name is Eric Bjork and I'm an Applications Engineer with Gates. In this video, I will give an overview of our belt drive design software called DesignFlex Pro. DesignFlex Pro is a free program available to download at www.gates.com. DesignFlex Pro is a two-point drive design program, meaning it only works for a drive containing two shafts. If you need to design a drive containing 3 or more shafts, you can use our other design program called Design IQ, which is also available to download at gates.com. DesignFlex Pro only uses products available in the Gates Industrial Power Transmission Systems catalog. If you're not familiar with Gates power transmission product lines, then I urge you to research them before using the program. The catalog is available to download at gates.com/catalogs. When first opening the program, you will need to fill out your user information. This is information that will show up in the final drive report, so make sure you only provide what you want showing up on the actual report. After entering your user information, you will see this screen. This is going to be the main screen for DesignFlex Pro. Up on the top left is our desired belt line. This is where we choose whether we want to design with a synchronous belt, a V-belt, we want to calculate tension, or we want to replace a roller chain drive. We can expand these further to choose specific product lines to design with. Below the desired belt line is going to be our input power section, where we put in either our motor power or the power we want our belt drive to transmit. We have options to choose between an electric motor, a 3-phase motor, and if you're using a VFD or soft start. We can change the power units between horsepower, kilowatts, watts, and then also torque, which comes in Newton meters, kilogram meters, inch pounds, pound feet, and then a PS unit. Next to RPM is where we want to put in our input RPM. So either our motor RPM, or if you're running off a jack shaft or something else, we want to put that RPM. We have an option to enter a motor efficiency, which is default at 88%. If we are running an electric motor, and the power and the RPM correspond to a standard NEMA electric motor frame, then we can choose the motor frame from the motor frame drop-down bar, and this will automatically include our shaft information, which is on the right hand side, and we'll get to that a little bit later. Below this is our gearbox speed ratio if we are using a gearbox. The default is at 1, meaning we're not using a gearbox. If we are, then we want to enter in the ratio, and the program will automatically calculate a new output RPM. Again, if we're not using a gearbox, then we just want to leave it at 1. Below the gearbox information is our service factor information that the program will use to design the drive. The default is a 1.2 for V-belts and a 1.6 for synchronous belts. If you're not sure if that's going to work for your drive, then you can hit the Help button and choose specific characteristics that your drive will see that will determine a correct service factor. The different options we can choose from are the driver characteristics, which is either a uniform torque, which is like an electric motor, or a higher non-uniform torque, like a diesel engine. We can choose the type of service, which is how long the drive will be running, and we have options between up to 8 hours daily, 8 to 16 hours daily, and 16 to 24 hours daily. And then we can choose the driven characteristics, or what our belt drive is going to be driving. And this is going to be in terms of shock loads. So this ranges from all the way to light loads, all the way up to extreme shock loads. And as you can see, as I change these and hit OK, our default service factors will change depending on the characteristics that I chose in the Help menu. Moving to the right is where we're going to enter in our desired driven speed. This is also where we're going to enter in our speed ratio. So we can either enter in the nominal RPM of our driven equipment, let's say 1000 RPM, and this will automatically calculate what the speed ratio is, which is 1750 going to 1000 RPM is a 1.75 speed ratio. The default for the program is to speed down. If we want to speed it up, then we hit the speed up button and it'll make it a speed up drive. Conversely, if we don't know what the final RPM we want is, but we know what speed ratio we want, say a 3 to 1, then we can enter in 3 next to the speed ratio, and it'll automatically calculate what that final RPM is. On the right are tolerance bands that the program will use to define the different components. So in this case, the default is plus or minus 4%, so the program will look for any drives that work with a final output of 560 RPM to 606.7 RPM. Below your speed ratio input box is our center distance. So our nominal center distance is the center distance we'd like to design for, say 24 inches. There are also tolerance bands on the right, which the program will use to find belt drives, so the default is going to be plus or minus 10%. We can change the units for center distance from inches to millimeters, feet, or meters. Below our center distance input box is going to be our materials that we can consider for the drives. So we can choose between standard materials, stainless steel, nickel plated, and then we can also choose specialty products such as our ACHG sprockets, light duty shivs, and multi-duty shivs. And then we can choose between what bushings we want to use, such as QD, taper lock, and minimum plane bore. Specifically choosing one of these will give the program something specific to look for, so it may limit the amount of drives that we see when we hit design. So if you don't know exactly what you want, then I wouldn't recommend changing any of these settings. Moving over to the right is where we're going to enter our driver, shaft diameter, and shaft information, and our driven shaft diameter and shaft information. So what we can enter is the shaft diameter, shaft length, the maximum OD we'd like to see on that shaft, and the maximum width. If we don't know any of these values, then we can leave them unspecified and the program will work as normal. So now I'm going to quickly go through a synchronous belt drive design. So I'm going to go over to the top left in the desired belt line and find synchronous. I'm going to hit the plus button to expand it to see the options I have for my synchronous product line. I can expand these further to see the specific sizes I can design with, or I can just choose the product line box and it will choose every size to design with. So in this case, I'm going to design with a polychain carbon belt drive, which includes an 8mm pitch, a 14mm pitch, and a 14mm extended length. For this example, I'm going to keep the electric motor box checked. I'll use a 50 horsepower input at 1750 RPM, and when I choose the motor frame, this corresponds to a NEMA 326T frame, so I'll choose that. I won't use a gearbox in this example, so I'm going to leave the gearbox ratio at 1. And for the service factor, let's change this to a uniform torque, continuous service, and let's use a heavy shock load. For my RPM, let's say I want a 2 to 1 speed down drive, so I'm going to change the speed ratio to 2, and that will automatically calculate my nominal output RPM of 875 RPM. And then the center distance, I'm going to design for 30 inches. I'm not going to change any of this because I don't know specifically what I want. And then, as you can see, the driver shaft diameter and shaft length is already input because I chose the NEMA 326T frame. And for the driven pulley, let's say for this example I don't know what it is, so I'm going to leave that blank. So now that I have my information here, I'm going to go to the top right and hit design.